All right, so I'm going to start a new note here and list a few things I want to cover today. So the first thing is statics versus dynamics. The other one is phases. A fluid refers to something. A fluid can either be a gas or a liquid. Sometimes confusing, but just that's the semantics. So normally you hear the word fluid and you're like, well, that means a liquid. Well, in engineering and physics, a fluid also refers to a gas or some combination thereof. So fluids can be either gas or liquid. I also want to look, and we'll spend a lot of time looking at Bernoulli's equation. O-U-L-L-I. Bernoulli's equation is just an energy equation. And it's the Bernoulli's principle is what the blower door test is based upon. So when we get to the blower door, you're like, okay, that's Bernoulli in action. Also want to look a little bit at some heat transfer. Technologies. Okay. So first of all, I just want to give you one little example. So what's atmospheric pressure? So we'll do fluid statics first. Anyone remember what atmospheric pressure is? The value. So P-A-T-M. Yeah. Okay. So you can call it 1 bar. It's also 14.7 psi. It's also I think it's 101 kilopascal. So let's look at all three of these units. So the 1 bar is kind of uninteresting, right? It just means, okay, so it's 1 atmosphere. Like, duh. Okay, so we're all at 1 atmosphere. If you climb higher, there's less air on top of you, so the pressure goes down. If you go lower, there's more air on top of you, so the pressure goes up. Where does this 14 psi come from, or this 101 kilopascal? Yeah, but what's making the pressure? Yeah, and so where are these molecules that are making the pressure? Yeah, they're all stacked above us, and here's the kind of the funky thing. So the atmosphere is only about 60 miles thick, right? So all the air we use is about 60 miles thick. We could take a 1 inch, a 1 inch square, a 1 inch tube, make it 60 miles tall, and there are about 15 pounds of air in that 60 mile tall by 1 inch cylinder. That's where the pressure is coming from. The other thing to note about atmospheric pressure is that it's the same in all directions, right? So you've got all this, you've got gravity here pointing down, and again, this thing is just 1 inch by 1 inch. It's 60 miles tall, and there's only 14.7 pounds of air. It's kind of wild. I mean, you could take all of that air and compress it to the same density as water, and it would fit in 2 gallons. Like that whole 60 miles of air, just squish it down, compress it. You got only 2 gallons of air between you and outer space being compressed. Kind of weird. There it is. Okay. Kilopascals. So obviously we know that we know that this stands for pounds, which is also LBS. We know that this is square, and we know that this is inches. So in this case, we're looking at force per area. And I've got equal signs in here, so we also know that bar must be force per unit area. We know that PSI is force per unit area. This thing, kilopascals, it's also force per area. And you are likely to encounter that. So let's just take a look at what a Pascal is first of all. So again, getting back to our every single problem is 3 in 1. This is the number, this is the power of 10, and there's the units right there. So let's look at the units first. The Pascal just equals 1 Newton. So 1 Pascal equals 1 Newton per 1 meter squared. Okay, everyone kind of knows what a pound is. It's not always that clear what a Newton is, so let's just go over that quickly. Let's go back to, well, Newton's first law. We know that F equals ma. And in the case of this equation, we know that force is measured in newtons, we know that mass is measured in kilograms, and we know that acceleration is measured in meters per second squared. If we were doing conventional units, this would be pounds, or I'm sorry, well, yeah, actually, here's the fun, confusing part. That's measured in pounds. This is measured in pounds. And this is measured in feet per second squared. So the seconds are the same, feet are different from meters. This is actually pounds force. So sometimes you'll see pounds force, and sometimes you'll see this as pounds mass. So you're like, well, how much does a pound of mass weigh? Well, it weighs a pound. In SI units, a kilogram does not weigh a Newton. As it turns out, and I'm just going to show you kind of the quick and dirty. If I run it this way, if I have 1 kilogram, what's 1 kilogram? 1 kilogram is a liter of water, or about a quart of water. It's also 2.2 pounds. We know what that is. And if I multiply that by gravity, which is about 10 meters per second squared, I'm going to come up with 10 newtons. Because 1 newton equals 1 kilogram per 1 meter per 1 second squared. So that's mass, and this is force. Okay, what does this have to do with air pressure? Well, again, let's just go back to this chunk of air, except now let's draw a, instead of an inch by inch column of air, let's just draw 1 meter squared column of air. And again, it's that full 60 miles high. So there's more air there, but then let's go actually out and figure out how much more. And then also figure out if we can get back to this 101 kilopascal. So we know that 1 Pascal is just 1 Newton per 1 meter squared. What's a Newton? Well, I just told you that 10 newtons is about 1 kilogram, so 1 Newton equals a tenth of a kilogram, right? Equals, what's that, 100 grams? What's that in ounces? About 3 ounces, is that right? 20-something, 3 ounces? So something that weighs about 3 ounces is about 1 Newton. Now, let's see if we can't derive this 101 kilopascals. And let's just do it, let's do it backwards and figure out how many or how many kilograms of air is in this column. All right, so let's work it this way. So 101. Now let's just use 100. It's easier than using 101. Pascals. So 100 kilopascals equals, and I'm just going to write the whole thing out, 100,000. And what is that? Newtons per square meter. Right? Because I know 1 Pascal, again, just as I wrote it here, yeah, 1 Pascal is 1 Newton per square meter. Now, think about this again. I just told you that a Newton is 3 ounces. So imagine, 3 ounces, and I don't know, there might be just, 3 ounces of coffee left in my cup here. Imagine I took and spilled it on the table and the table's about a square meter. It's not much weight, right? So it's not very much pressure. So a Pascal is a relatively small amount of pressure. Way less than a PSI. 1 Pascal is way less than 1 PSI. But let's figure out how many kilograms of air are in that column. In fact, I'm just going to take a quick pause. I'm going to let you work on that and tell me how many kilograms of air are in that 1 meter column that's 60 miles tall. I'm just going to take a quick pause. Disconnect the projector. I'll do it myself, then I'll come right back.